Hello everyone. In this section, we will discuss about TensorFlow graph visualization using TensorBoard. So these are the topics we are going to cover. First, we will discuss what is TensorFlow graph. After that, we will discuss some basic examples of graphs. First, we will discuss what is TensorFlow graph. So basically in TensorFlow, the graph specifies the nodes and an edge. While nodes take more tensors as inputs and generate a given tensor as an output. So the edge is denoted as a tensor and it will operate a new tensor and it always depends on individual operations. So if we are talking an example in TensorFlow, then the graph is the backbone of the example. In simple words, we can say that the graph is the combination of nodes that defines the operation in your model. TensorFlow graphs are like a data structures that stores a set of TensorFlow operations objects that specifies the unit of computations, where objects will be a tensor that specifies the unit of data. So in this figure we have created a operations, constant and a variable. So let's start with the basic arithmetic operations, like we have to do a addition and as well as multiplication operation in it. So to visualize this, we will create a variable, a constant variable, that is 3. So after this, we are going to use a add operation on the input and the name associated with the addition node on the graph. So now we will discuss some basic example using of graphs. In this example, we have declared two variables, that is var1 and var2, and assigned an integer number, that is 5 and 8, using TensorFlow. After this, to perform this task, we need to call the tf.multiply function, tf.add function, and tf.add has three arguments, that is var1, var2 and the name parameter, where var1 and var2 are the values to be added combined, and the name of the operation name is add. For this, we have imported the TensorFlow library and use the function tf.compat.v1 disable eager execution function for running the session. After creating the variables, we have used the basic operation method to display the addition of two tensors. Now in the next example, we have created two variables, that name is random val and the sample val. After that, we have used the operation function, that is tf.add, and assigned the values in it along with the name parameter. We have used also tf.multiply function, and within this we have assigned same variables in it along with the name of the operation, that is multiply, and also we have used the power function in it. So after executing this code and using the running session as by using tf.compat.v1 session and pass the parameters in it, that is power operation and the result. So after executing this code, the output comes here. So in this example, we have to check the version of TensorFlow. After this, we have to able to use the TensorBoard. For this, we have used the command, that is load extension TensorBoard, and for that I have used the command load extension TensorBoard. After that, I will import the required libraries, that is TensorFlow datetime, and for running the session I have used the tf.compat.v1 disable execution function. And now I will load the dataset, and for this I am going to use the MNIST dataset by using tf.keras.dataset.mnist, and then I load the train and test data as xtest and ytest. Since the input features are between 0 to 255, so I will just normalize it by dividing by 255. So after loading the dataset, now I am going to create a sequential model with a single dropout layer as model tf.keras.model sequential. So in the first layer, I have created a flattened layer that will take the input images of size 28,28. In the second layer, I have created a dense layer with 512 neurons and the activation function as ReLU, dropout rate, that is 0.2. And the final output layer has created a dense layer with 10 neurons and the activation function I have used, that is softmax. Now we will display the summary by using the model.summary function. As you can see that the output shape comes in the 512 neurons and the 10 outputs. So before I call the fit on our data, I will just specify the. So here I have used the model.compile. Within this I have used the optimizer, that is adaptive grad, and the loss function, that is parse categorical cross entropy, and the matrices, that is accuracy. Now also I have used the tf.keras.callbacks TensorBoard, and within this I have assigned the path of this and the histogram value, which means I want the histogram computation for every epoch. Now to access that in the support interface, we have to use the command TensorBoard log dir and the path name. So as you can see that this is the graph of the loss and the accuracy function. So with this we have completed the TensorFlow graph visualization.